Alright guys, let's go back to Algebra 2. If you didn't learn exponential and logarithms, what you should have, specifically logarithms, we're going to have a quick crash course. So here we go, hang on. The best thing that I would say is that natural logarithms and exponentials are inverses of each other. Just like 10 to the x and log base 10 are inverses of each other. Okay? So those are flip-flops of each other, just like these are flip-flops of each other, because this is the same as log base e. Okay? The second thing that I'll start off by saying is that the best way to solve an exponential is to rewrite it as a logarithmic, vice versa. Best way to solve a logarithmic is to rewrite it as an exponential. Reverse power rule helps big time with that. So the parent function natural log of x, the domain is greater than 0 and to infinity, because there's a big old vertical asymptote at x is equal to 0. And there's a very important pivot point at 1, 0. This is on the natural log of x graph. So if I said the natural log of 1, what would you say it equaled? 0. If you didn't know that, you could say natural log is the same as log base e. And the log base e of 1, if I said is equal to something, reverse power rule says I'm going to change this logarithmic into an exponential, because then I can see it better. Start from the base, nice little sideways heart, e to the power of question mark equals 1. What would question mark equal? 0. So that's why this is 0. So there's one thing to remember right off the bat. Natural log of 1 is 0. You have to remember.
That's reverse power rule?
Wait, what?
You said reverse power rule. You said that heart thing was...
Oh, reverse heart method. My bad. Did I say power rule? Nice catch. I'm sorry. Thanks for clarifying that. This is a reverse heart method. Okay. Natural log of e works the same way. If I had log base of e, which is natural log of this e, well, what would the reverse heart method say? X would be 1. That's why natural log of e is 1. There's the algebra, manipulation, okay? You have to memorize these. If you're multiplying, you add 2 separate pieces. If you're dividing, you subtract 2 separate pieces. And the one most people forget that are the hard ones, very, 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 very important, is this one right here. N times natural log of a is the same as this. Now watch what I'm about to show you. The natural log of a to the n in parentheses is the same as n natural log of a. Multiplication is occurring. Now let me show you other things that are not the same. If you put natural log of a to the n like this in a calculator, let's say that we have natural log of, because this n is probably throwing you off a little bit. Sometimes it throws people off. Let's say we have this. This is the same, if you put this in a calculator, as that. Which is the same, kind of like sine squared pieces, like that. Not the same as that. So if you need to over parenthesize some of these pieces to understand what's happening, please do so. Yeah?
But there it doesn't have a parentheses.
So here we go. Can someone tell me, if I told you to put parentheses, where do they go? Around the 3x. But if I wrote something that looked like this, where do the parentheses go? It's still around only the 3x. Because everything that follows, a sine, cosine, anything trigonometric, tangent, anything that follows after that, whatever's attached to the first term through multiplication, that's what's considered to be in parentheses when it's not written. Some of you might be saying, well, why wasn't this in parentheses? Because the rule is, if a new trigonometric function is initialized, then it's like you create this new angle. Did you all understand that? Okay. The same rule applies with natural log, but a lot of people miss natural log stuff because of algebra 2. They forgot natural logs, but mostly because of what I'm about to show you, where pieces belong. So if I have a natural log of x squared plus 1, you should see this like that. If there are no parentheses, if there are no parentheses written.
But if there's not a term, can you bring that 2 out then?
But if I have, yeah, and then you could change this to 2 natural log of x
But if you just had
plus 1.
natural log of x squared, yeah, if there's no parentheses plus any, can you bring that 2 out? You're saying we can't.
I see what you're saying. I see what you're saying. Listen. If you have this with no parentheses, the way I want you to interpret that is this. Okay? I know, that's what I'm saying. Because this, you weren't listening, is if you put it in the calculator like that. Okay? The way I wrote it over here with the no parentheses, I want you to look at this as this. Go with me? Okay. That's it. Let's start working some problems. I think that's enough review. Before I show you something new, this is a new, because guys, remember I taught you power rule, and you thought it was the best thing since sliced bread? And you knew exactly what to do. Well, what if I have this, and I asked you to integrate? From the skills that you know right now, what would you rewrite that as? X to the negative 1, right? It's not square root. Then what would you do?
It would become x to the 0.
It'd become x to the 0 divided by the new power. You can't do that. You cannot divide by 0. So reverse power rule we're learning right now. The only time I cannot do that is either in this form when the exponent is negative 1, or in this form when the power is 1. Do you see that? If you see that, the integral of 1 over x dx is equal to the natural log of the absolute value of x. Now, look. Some of you are like, why is that absolute value there? What's the domain of natural log?
X is greater than 0.
It can only be positive. That's why the absolute value is there. Okay? Now let's go back. It's been a while. What's the derivative of natural log of x? 1 over x. That's it. Times the derivative of x, which is dx, which is just still 1. So that's where this comes in, guys. If I did this chain rule, it'd be 1 over the stuff times the derivative of the stuff. That's right there, your integrand that we're coming backward from. That's a cool moment, right? So what other questions do you have right now before I start working out problems? Okay? So that was the derivative. So now I'm going to do the integral, which is right here. So let me go to the practice problems that are easier to see. Right here. What's screaming at you right now?
Just the fact that it could be a thing since x is on the denominator.
True. Before that, What is screaming at you to do rewrite? Constant multiple rule. There's a form we recognize now. We just learned it. So this will equal the natural log of the absolute value of that, constant multiple rule of the 2 back in, and then plus c. We good? Some of you would say, can't we do this too? Or would it go into here? Right? It's like, ooh, where does it go?
It doesn't really matter because the square is going to take the negative out anyway.
True, but the square of something like this is different than the square root of something like this, per se. If you graph these two, they would look different.
Well, yeah. But for absolute value.
Like the square root of x, the first one, if you graphed it, so it first takes the square root. Some of you probably have never thought of this before. I just found this out like a year or two ago. This square root of x would be drawn here, and if I squared it, it would become a line. But this other one, where it was x squared, I would draw it here, and if I square rooted it, it's a plus or minus, and it has this absolute value field to it. So this almost means and feels like that. Okay, but my point is to all that, just little extra math, just keep the 2 out front. When you have the absolute value, keep the 2 out front. It's so much easier to work with. Okay? So let's keep going. Constant multiple rule of the 2. 1 over x dx. Do I need to change my bounds? No, because I did not have to integrate. Now I'm about to integrate. No, not because I didn't have to integrate. I didn't have to use substitute. Nice. What's the integral? 2 times the natural log of absolute value of x. No.
No, come on, Christian. It has bounds.
1 to e, it has bounds, right? So, looking at this, I would constant multiple rule that 2 out. And I'm basically going to ask myself 2 times whatever the answer is to this piece right here. So let's plug in our upper bound of b and find f of b.
Does the bracket go outside that cool line thing? Or
Yep, outside. Yeah.
Okay. And does bracket mean anything different than parentheses?
Nope.
It's just constant.
Means the same. It's constant multiple, you're just going to distribute that 2 onto it. So what's the natural log of absolute value of e? 1. Now let's plug in our a value so we can find f of a. What's the natural log of 1? 0. So what's the answer? 2.
Couldn't you skip like that line and just have the brackets and put the bounds?
Yeah, so those of you who are wanting to write it as far as your notation is concerned, and I'm just trying to help you out because in college, I just don't want them laughing at you per se. So looking at this, yes, it could be the same like that. But in
college, they would want you to do.
They want you to do the line.
Plus the bracket afterwards.
So I see what you're saying. In college, they would want you to do that. But I do the bracket extra just to help you out right now. They're not going to laugh at you if you put that extra bracket. Because they reinforce constant multiple rule. They know.
Wait, so that would still be constant multiple rule?
Yeah, this is the same as that. Nice questions. Cool? Alright. They become involved. They become more involved. I know. We're almost done. Hey, thanks for hanging in there, guys. Today's a big day. Okay? What do I do?
Which one are we doing?
We're doing this one right here.
You don't have to use subs if you want.
1/2. But you can't because of this 1. If it was like this, then you could GCF out a 2 in the denominator. Then you could pull out between multiplication a 1/2.
Could you?
Okay, now listen. Go ahead.
Well, I was gonna, so you wouldn't have to use substitute.
I do have to use substitute.
So you couldn't take the entire denominator, put that in parentheses.
Yep, that's exactly what I'm going to do.
No. I mean, and then put that whole thing on top and make that to the power of -1.
Oh, he's saying this. He's saying, can you change this to all of that to the -1? Do you see what I'm saying? Why do you not want to do that?
So you're gonna, if you integrate, you will end up dividing by 0.
You're going to divide by 0 for 1, so you need it to be natural log of the absolute value of x. Right there, you should see it. He said it right there. You should see that you're not going to be able to integrate this. That's pretty cool, right? The other thing is this -1, you're used to seeing it with 1 term, not 2. Okay? Look. Let's do u. And I really hope that the moment that I was hoping for last class happens in the next 3 minutes. Here we go. U is that. What's du? 2dx. Look at the scraps. Look at the pins that we just knocked down. We just knocked down that. With this, use substitution. So my rewrite is going to be 1/2 du, because we're accounting for that by moving it to the left, of what? 1 over u. This, no. We haven't integrated yet. We haven't integrated. We've just rewritten. This is something new we learned today. What's the integral? Natural log, absolute value of u plus c times 1/2. Now we know the 1/2 is there, but 1/2 c is still c. Why were we able to integrate it here, but we weren't able to integrate it here? It was one variable.
One term coefficient.
And what was the coefficient of that variable? A +1. That's why. Okay?
It makes a lot more sense with the natural log stuff.
And you needed to see it. You needed to see more examples to get there.
I feel like I could have got the 500 points today.
Okay, but it's still wrong.
Well, that's not cool.
Why is it wrong?
Because you still have to do this.
Because you have to answer in terms of x, because it isn't a definite integral. I hope it was rewarding enough, Alec. All right.
Yeah, that makes sense.
Any questions before we have a couple more. We're going to go to the hard ones now. They're not hard. You just got to see it. And they're hard if and only if your derivatives are not like that. Try to answer as quickly as you can. What's the derivative of sine? Cosine. What's the derivative of cotangent? Okay? See, that's what I'm talking about. If you can't see it like that, the next part will be difficult because your derivatives aren't fast enough. And they're not fast enough for 2 reasons. 1, it's been a minute. 2, you've been anti-deriving this whole time. It's hard to think of derivatives that fast now.
Or just cotangent in general.
Oh, cotangent is negative cosecant squared. Okay? So here we go. Let's do the difficult ones. Let's do this right here. What do you think u is?
1 plus natural log of x. Or just
You're right.
x.
This is the first time that I've seen where the numerator became u. Like all of the ones that we've done before, the entire denominator or pieces of the denominator were u. Check it out now. So what's du? 1 over x dx. Look how many pins we just knocked down with this. Okay, here we go. So a lot of stuff. 1 over x dx is right here, and an understood 1 that exists in the numerator. X plus, or 1 plus natural log of x is all u.
Wait, we've run into a problem.
Uh-oh, what problem?
When we're doing the bounds.
Okay, we got to do the bounds. We have to change the bounds, right? So the limits of integration will now become in terms of u. Let's go through the nether portal. Here we go. What is that 1 going to become?
0. 0 plus 1.
1, right? So 1. And then plug in the e into the nether portal. What do we get?
1. Wait. Dang it.
No, it's okay. So natural log of e is 1. Add with 1 would give me 2. And what's our integral going to be? U cubed du. No 1/3, no 1/2, none of that mess on this. Okay? What is the integral? From, do we have to go to x? Nope. Let's finish it off in the nether world. Okay? So we're going to get what? 16 over 4 minus 1/4. Done. Notice the box. Cool? Alright, let's do a little bit. We'll do 2, maybe 3 more, and we're done for the day. Okay? So that one was with 1 and e.
Where would you rank?
Let's try.
Balance scale?
To me, if your derivatives are slow, I would probably rank these 6 to 7. Because it's a you know it or you don't. Because you would miss the whole thing or you'd get the whole thing is what I've seen. Okay? What's u?
Natural log of x.
Mm-hmm. What's du?
1 over dx.
What's the rewrite?
U to the 4th du.
Nice. What's the lower bound?
1.
What's the upper bound?
E.
No.
2e or 2.
2.
Yeah.
Because the natural log of e squared, we have to remember that rule, is the same as bringing that in front and leaving that. Because the power of the argument, the stuff in parentheses, can become the coefficient. And what is this again? 1. So 1 times 2 is 2. So this would be u to the 5th over 5 from 1 to 2. What's 2 to the 5th? 32. You with me? You gotta be good with these fractions. Some of these fractions you can be in the hundreds on a quiz or on a test. Okay? Alright, let me see. A couple more and we will call it. These are what we're going to do in more depth next time, but you have 1 or 2 on your homework, I believe. Okay? Tangent is the same as sine over cosine. So u, let me do correct notation so that you can see it. U will equal cosine. You see it?
So why can't you just integrate and say that integral tangent is secant squared?
Because the integral of tangent is not secant squared.
Negative. What is it?
The derivative of tangent is secant squared.
Oh, secant tangent. No, it's not.
Exactly. So the derivative of tangent is secant squared. So the integral of secant squared, that's tangent. But we're doing the integral of tangent, not the integral of secant squared. Well, u substitution is negative sine of x dx. And up here, let's see how many pins I just knocked down with this u substitution. With this u assignment, you see that negative?
Yeah.
So it'll be negative integral du
Well, let's get
over u,
negative natural log.
which is the same as negative 1 over u du. Here's the box. Negative natural log, careful, of absolute value. Don't forget that. Those are other points that are naturally are taken off that people forget, like the du dx and stuff, plus c. So it's the negative natural log of cosine of x plus c. And yes, you could bring in this negative. And this negative actually goes here, those of you who are wondering. And then the absolute value. So you could bring, by the law of logs that you refreshed today, that inside as the power. This is the, so this is the reciprocal. This isn't arc cosine. Nice. It is not arc cosine. It's the 1 over cosine, which is secant. And we're going to talk about that next time.
So would putting the negative natural log be wrong?
No, this is correct. This is why I say a lot of times you should keep it inside or outside. But still remember what it's equivalent to. It's because you could see this on a multiple choice question.
Or bonus points for simplifying for that? Why did you use cosine x when you substituted it and not sine x?
Because, look, that's a good question. If I use sine,
They seem equally good.
then the du is cosine of x dx.
And you wouldn't have a negative.
This cosine of x dx is not the same
Oh, wow.
as this one. This cosine is in the denominator, this one's in the numerator. That's why I can't use that.
Oh, because that one is 1 over.
It has to be in the denominator so I could use that natural log. Otherwise, you just saw this one doesn't work. It's not, they're not on the same ground level, if you will.
So you have to like figure it out before.
Yep. And sometimes when you throw that ball, you're not going to hit a strike. You're not even going to hit all 9. So that you can pick up the spare the next time. Try again. Cool? Nice job today, guys.